Hello, welcome back. I'm going to take you through a second example here on the student's t-test here. Okay, looking at another example here. Manager of a restaurant chain goes to a seafood wholesaler and inspects a large catch of over 50,000 prawns. Knowing that the population is normally distributed, you will buy the catch if the mean weight exceeds 55 grams per prawn. Okay. A random sample of 60 prawns is taken. The sample mean weight is 56.2 grams with standard deviation of 4.2 grams. Conduct a one-tailed hypothesis test, which would be one of these two, because this is the two-tailed, with significance level at 0.05, which is 5%. Determine whether the manager should purchase the catch. So, step one, null hypothesis. So our null hypothesis in this case is going to be that the HO is the mean weight is 55 grams, okay, per prawn, okay, and then our alternative hypothesis, H1, is going to be that the mean weight is more than 55 grams per prawn, okay, because that's when we want to, that's when he says he wants to buy the catch if it's more than 55 grams. So that's what we want to know when what our probability is that it's going to be more than 55 grams per prawn. Okay. So there's our two hypotheses. State the significance level. They told us here that it is 0.05, right? Okay. So I'm going to put in 0.05 for this part down here. Calculate the value of the test statistic. We will. So we'll say that the test statistic is, so we'll leave ourselves a spot here to fill in that blank after we calculate the p-value. Now we got to figure out which one of these we want. Okay, so the null hypothesis is that it's 55 grams. We want to know when our mean is more than the null hypothesis mean. So we want to pick this one here. We want to know when is it going to be greater than the let's see, when it's going to be greater than the 55. Okay, so now it's calculator time. So we go into stat. We're going to go over to test, and if you forget where it is, it says students t test. So you know this test. So there's our t test. Push enter. Again, we have gotten the statistics. We don't have the raw data. There is another example where there are some examples where you put the raw data in. Okay, but we want the stats. So this is like these three here are what we found. Okay, so this one's going to be the advertised one. So it says known that the population is normally distributed and the mean weight. Let's see. You will buy the catch if the mean weight exceeds 55 grams per prawn. So we're going to do 55 here. And then we found that in our sample that the mean weight was 56.2, right? And our standard deviation was 4.2. And the number of trials was, let's see, there was 60 trials because we had 60 different prawns that we measured, or that whoever did this measured. Okay, so we want to know when we're going to be greater than our null mean, right? So we basically want to know when we're greater than 55, which is this one up here. Okay, so we go down here to calculate, and we cross our fingers. Okay, originally when I had that, my numbers were off a little bit because we selected this, but I did not push enter. So you got to select that and push enter, and then that box will go away, and then it will go there. will now be highlighted over there. And now we do calculate, and now it should give us the, oh no, error domain. Hold on a second. All right, when I went back in, it took out, somehow it took out my standard deviation, so 4.2. Everything else should be good here because we're already on that one. Now we should be good. There we go. Okay, so our test statistic is 2.21. 2.21. Okay, and then our p-value is 0.015. So our p-value is, so we got 0.015. Is that less than or equal to 0.05? Okay, so it says right here, reject HO if the p-value is less than 0.05. And our p-value is, so that means that we are going to reject HO, which means that the mean weight is going to be 55 grams. It's actually going to be more than 55 grams per prawn. So that means that we conclude that the mean weight exceeds 55 grams per prawn, so the manager should purchase the catch. Okay. Okay, so there's another example of a t-test. Okay. Next example, fat content in grams of 30 randomly selected pasties at the local bakery was recorded. All this raw data here. For a mean fat content of pasties made at the bakery, mu, that mean, conduct a two-tailed t-test of, where HO is the mean equals 16 grams on a 10% level of significance. So, step one, null hypothesis. So, HO is going to be that the mean fat content is 16 grams. So, basically what they're claiming. So, mean fat content is 16 grams. Okay, so that means the alternative hypothesis is that it's not 16 grams. Okay, mean fat content not 16 grams. State the significance level. They told us that it is 0.1, which is 10%. Okay, so down here, I'm going to make our little inequality. I know it says step 1, step 2, but I like to go to step 5. As soon as I get my information, 0.1, and then we'll figure out what our p-value is there. Okay, calculate the value of the test statistic. So t is going to equal, we'll figure that out when we put it all in our graphing calculator. And it even says right here, a two-tailed t-test, which would make sense because you're not sure if it's going to be higher or lower than 16 grams. So that's when you're not sure if it's going to be higher or lower, it's always going to be this one right here. Okay, so now what we want to do is get our graphing calculator out. And since we've got a bunch of raw data, whenever you have a bunch of raw data, you always want to go into stat and edit, because you're going to edit a list. So again, that's stat and then edit. And then you're going to edit your list. Now I went ahead of time and put all this data in the list here, all the way down to 30. You're just going to have to believe me because this will take a while to get down there. Okay, so once you get all your data in, we're going to do stat again. And instead of edit, we're going to go over to test. And we're going to go back over to our t-test. Push enter. And then now we actually have the raw data, because it used to be in stats, which we had to enter all this stuff in, but now since we have the raw data, it's actually going to calculate some of that stuff for us. So the raw data, and then what we want to do is we want to go in and say, it even tells us the HO is 16 grams. So here's our mean, the null part of the mean. This here is going to be 16 grams. Okay. And then our list, we made our list in list 1. So we do frequency list is L1. If that's not already showing up for you, then you just do, let's see, where's L1 is right here. So you do second, and then number 1 would pull up the list 1 for you. Frequency is 1 because each one of those represented one piece of data. We want to go into the not equals part. So make sure, especially if one of these others is already highlighted, make sure that when you go into this here, instead of it just blinking, you got to push enter so that it makes that one, nothing else is highlighted. and then go down to calculate, and it will come up with all of our important juicy information. So our t is negative 0.40. Okay. And then our p-value here is 0.691. 0.691 is our p-value. Okay. Now, is 0.691 less than or equal to 0.1? That is not true. Right? So it says reject HO if this is true. Since it's not true, we don't reject. We do not reject HO. Okay? So that means we actually accept it. We accept HO. And then back up here, HO is our mean fat content is 16 grams. Okay? So basically, we cannot conclude that the mean fat content is significantly different from 16 grams, is basically what they're getting at. It's a weird way to state stuff, I know, but we accept HO. Okay. So basically we say that the cannot conclude that the mean fat content is significantly different than 16 grams. Okay? Okay. That is the third t-test example there. So hopefully this t-test stuff will make a good amount of sense now. Okay? If you have any further questions, please feel free to ask. Thanks.